Concept 2, identifying constant and variable rates of change in data. Alright, so remember that rate of change is basically the same as slope. And if we can identify that the rate of change, so the slope, remains the same, if it's constant, then we know our line is going to be linear. Okay? If the rate of change is constant, it's going to continue to increase at the same amount, so it's going to be linear. If it's variable, then we're looking at something that either bends or has breaks in it or has little mountains and valleys, and that's not linear. Okay, our line is curved or broken, so it's not linear. Okay, and we're looking to do this so if we are given a table, instead of having to graph the whole thing out, we can look at our table and say, oh, my rate of change is constant, so I know it's linear. All right, we still might have to graph it out for other reasons, but if we're just trying to determine if our equation or our data set is linear, we can do that from our table. Okay. To do that, we're looking at our rate of change, so the amount that our value increases or decreases as we go up. Okay, so here x increases by 1, so it's a plus 1, and y increases by 4. Okay, from 1 to 2, x goes up 1, 4 to 8, y goes up 4, 2 to 3 goes up 1, 8 to 12 goes up 4. So I can tell, because y increases by 4 for every 1 of x, that this is going to be a linear equation, and my slope is going to be 4, my rise, over 1, my run. Okay, I'd have a slope of 4. All right, let's look at another one. Okay, so I've got x is 1, y is negative 1. Okay, and x goes from 1 to 3, so now we're increasing by 2, which is fine. We can increase by 2. And when y is negative 1, it then becomes 7, so that goes up by 8, plus 8. Okay, and then 3 to 5 is a plus 2, and 7 to 15 is a plus 8. And then 5 to 6, we got a plus 1. 5 to 19 is a plus 4. Okay, so now we got to be careful, because it looks like this is a variable rate of change, right? This is 8, but then this is 4. It looks like that changes, but it doesn't actually, okay? Because here our x is increasing by 2, okay? Meaning if I have my graph, my line is going to, it's going to be coming over 2 points, right, and up 8 points. You know, somewhere like up there, okay, over 2 and up 8. But if we look at it, that's pretty much the same as saying it comes over 1 and up 4. All right, and you can see that if you make it a fraction, okay, with my rise of 8 over my run of 2, okay, and if that's equal to my rise of 4 over my run of 1, then these slopes are the same. Okay, my rate of changes are the same, and they're constant. Okay, so this would also be a linear equation, a linear line, because even though my values change, my slope, okay, the rate of change, remains the same. All right. Okay, let's look at another one. So here we've got 0 to 1, 1 to 2, 2 to 3. So my x increases by 1 for all of these. Okay, and I can map that out, but I can just say it's plus 1 for all of those. And my y increases by 2, and then by 1, and then by 3. Okay, my x increases by the same amount each time, but my y increases by a different amount. That means this is not linear. Okay, not linear. And if I graphed this out, we would be able to see it. X is X is 0, y is 1. X is 1, y is 3. X is 2, y is 4. X is 3, y is 7. And you can see that's not a straight line. It gets kind of a curve to it, which means it's not linear. All right? Let's see, do we have any others? Okay, one more. And this one, we can see, again, x increases by 1 for each. Okay, so that makes our job easy. But now y is at 0, and it goes down to -1, so it actually decreases by 1. And then it goes down to -2, that's another -1, down to -3, so it decreases by 1 again. All right, that's fine. We can have a decrease. This just means we have a negative slope. All right, but that doesn't mean it's not linear. Okay, we still have a constant change, okay, a constant rate of change, and our slope is the same, so this is also a linear equation.